Covalent versus ionic bonds. We know atoms are composed of three parts: a nucleus containing neutral charged neutrons and positively charged protons with small negatively charged electrons orbiting around them at different energy levels. The goal of an atom is to be as stable as possible. They will attempt to do this by pairing all of the electrons in their outermost energy level, also known as their valence shell. Chemical bonding is a key part of the world around us. Lewis structures are used to represent atoms and their interactions with other atoms as they form bonds. Lewis structures are drawn by adding dots representing valence electrons one at a time in a clockwise direction, starting at the 12th position around the elemental symbol, followed by the 3 position, then 6, then 9. Do this until the valence electrons are all represented. When drawing ions, put brackets around the structure with the charge outside in the just above the top right corner. The key property when talking about chemical bonding is electronegativity. Electronegativity is the ability of an atom to attract electrons to itself. On the periodic table, electronegativity increases across and decreases down. Electronegativity values are given in relation to fluorine, which is the most electronegative element. It is given the value of 4, and all other elements are assigned a value based on 4 being the highest. The property of atomic radii is closely linked to electronegativity. Across the periodic table, the greater number of protons and electrons, while having the same energy levels, increase the attractive forces between the outer electrons and the nucleus. This compresses the atom, meaning the outermost electrons are closer to the nucleus. So how do we determine what type of bond atoms will make? It's pretty simple. You simply subtract the lesser of the 2 electronegativity values from the larger one. How does this determine what type of bond it is? If the difference in the electronegativity is greater than 1.67, the attractive forces of one atom are strong enough to pull the electrons away from the other to fill its octet. The result is cations, which are positively charged atoms, which would have lost electrons, and anions, which gain electrons, resulting in a negative charge. So what are some properties of ionic compounds? Ionic bonds generally form between metals and nonmetals because of the large difference in electronegativity. Cations and anions arrange themselves in a crystal lattice structure. In this structure, all ions will be surrounded by ions of opposite charges, so they are being attracted in each three-dimensional direction. Generally speaking, ionic compounds have high melting and boiling points. That's because the electrostatic attraction between ions requires a lot of energy to overcome. For example, table salt, which has the chemical formula NaCl, has a melting point of over 800 degrees Celsius and a boiling point of almost 1500 degrees Celsius. These compounds are also very brittle because any force will make opposite charges come closer together, which will then repel, breaking apart the structure. Ionic compounds also dissociate in water. The ions of the crystal lattice are attracted to the oppositely charged polar ends of water molecules. Because of the presence of free-floating electrons in the solution, it also conducts electricity very well. Covalent compounds are often solids at standard atmospheric temperature and pressure. So now, what are some properties of covalent compounds? If the difference is less than 1.67, then a covalent bond will form, where the electrons needed to fill each atom's valence shell will be shared amongst them. Most of the time, covalent bonds will form between 2 nonmetal elements. Within covalent bonds, there are 2 different levels of attraction: polar and nonpolar covalent bonds. In a polar covalent bond, the shared electrons are attracted to the atom with higher electronegativity, but not enough for it to pull them completely away. This results in those electrons spending more time around that atom, meaning that that atom will have a slightly negative charge and the other one will be slightly positive. This often results in the molecules orienting themselves with positive ends lining up with negative ends of other molecules. Polar covalent compounds are mostly gases or liquids because the attraction between molecules is not that significant. Polar covalent compounds will dissolve in water because of their polarity, which makes them attracted to the positive or negative ends of the water molecules. However, unlike ionic compounds, they are poor conductors due to the lack of free-flowing electrons. The cutoff for polar covalent bonds is 0.5. If the value for the electronegativity difference is less than 0.5, then the difference is negligible, and it is said that they are shared equally. This is exemplified in diatomic molecules like hydrogen or oxygen gas, where two atoms of the same element bond together. The elements that form diatomic molecules are hydrogen, nitrogen, fluorine, chlorine, iodine, and bromine. Because there is no attraction between molecules, covalent compounds generally have very low melting and boiling points. They are pretty much always gases at standard atmospheric temperature and pressure. So, is a bond between hydrogen and fluorine ionic or covalent? Based on the fact that it is two nonmetals, it would be fair to assume that it would form a covalent compound. But to determine if it would be polar or nonpolar, we will have to calculate the electronegativity difference. Fluorine, as we know, has the highest electronegativity, 4, and hydrogen has an electronegativity of 2.1. When we do the calculation, we get 1.9. As the difference is bigger than 1.67, it would lead you to believe that it is ionic. However, hydrogen fluoride does not form a solid like an ionic compound would. Instead, it has a much lower boiling and melting point. It boils at around 20 degrees Celsius and melts at around negative 83 degrees Celsius. So it is found as a gas or liquid, meaning it's polar covalent, not ionic. Additionally, the fact that it's a bond between two nonmetals supports this. It can be dissociated in water to form hydrofluoric acid, but this solution will not conduct electricity well because of the lack of free-floating electrons, again supporting the classification of polar covalent. Lastly, it's important to mention the noble gases, which do not form bonds because they already have a complete valence shell. They also are most of the time found as gases. So for question 1, we have to match the type of bond with the bonding elements based on if they're diatomic, metal and nonmetal, or nonmetal to nonmetal. So we have nitrogen, sodium and chlorine, and carbon and oxygen. So we know the two nitrogen atoms will be covalent because they form a diatomic molecule. Nitrogen forms a triple bond with itself, so there will be no electronegativity difference. So we can connect those two. And then the next one, sodium is a metal, chlorine is a nonmetal. So we know that even without calculating the electronegativity, that we can assume that those will probably form an ionic bond. So we can make that connection. And then for the last one, carbon and oxygen, just by process of elimination, we could determine that carbon and oxygen would form the polar covalent bond. This is supported by the fact that they're both nonmetals. So we can make that connection. If you really wanted to check, you could do the calculation for the difference in electronegativity, which you would find is greater than 0.5 but less than 1.67, which confirms that carbon and oxygen do form a polar covalent bond. Alright, for question 2, we're simply just calculating the electronegativity difference between lead and nitrogen. So lead has a electronegativity of 1.9 and nitrogen has a value of 3. So we're just subtracting the smaller one from the larger one. So subtracting the 1.9 from the 3. So 3 minus 1.9 gives us 1.1, and that's all it is the electronegativity difference. So for question 3, it's asking about the compound we just talked about, lead nitrate. So it's a solid with a high melting point. So it's asking, based on our knowledge of covalent, polar covalent, and ionic bonds, and the electronegativity difference that we just calculated, what type of bond do we think is being formed between lead and nitrogen? Well, we know the electronegativity difference is less than 1.67, so you might say that it's not ionic. However, we saw this with hydrogen fluoride, that there can be exceptions to this rule. So the fact that the lead nitrate is a solid with a high melting point reinforces the idea that it is in fact an ionic bond that forms between lead and nitrogen.